Hello, and thank you for joining. My name is Adam Pfister, and I'm joined by my colleague, Rami Aluta. Today, Rami and I will be discussing how to use Arcade, JavaScript, and Python in ArcGIS. For each section, we will cover the main points and then provide a demonstration. Let's start with Arcade. Arcade is a portable, lightweight, and secure expression language written for use in the ArcGIS platform. Like other expression languages, it can perform mathematical calculations, manipulate text, and evaluate logical statements. It also supports multi-statement expressions, variables, and flow control statements. With Arcade, you can create very simple expressions or complex expressions to make data-driven adjustments to your web maps and apps. Arcade is not a replacement for Python, geoprocessing, or developing standalone applications. When you think of Arcade, you should think portable and lightweight. For example, one very common scenario users find themselves in is needing to add additional fields to a dataset. Arcade allows you to add these fields without having to alter the underlying data structure. This is especially helpful when you are working with a layer that you do not own. Calculated fields from Arcade can be used in labeling, visualization, and more. The syntax for writing Arcade expressions is very similar to writing a formula in Excel. Expressions can also be carried throughout other ArcGIS applications. For example, if you write an Arcade expression to calculate a new field and save that in a web map, that calculated field can be used in other applications as well. Another key feature that makes Arcade unique is its ability to perform geospatial operations. If you combine this with the ability to create geometries for points, lines, and polygons on the fly, you can create some very powerful expressions that evaluate spatial conditions. Support for Arcade across ArcGIS is expanding. Shown here are the various profiles in which you can use Arcade expressions. A profile is the context in which an Arcade expression is evaluated and understood. This can mean that you are able to author an expression within a web map to be used to label features on a map, or you can create an expression that will be used to evaluate conditions to show or hide data in a list widget in an Arcgis dashboard. There are many different profiles that are well suited for their specific context and workflows. Look for this to expand in the future. Let's look at where these profiles exist when authoring a web map. Changing the symbology of a layer. Altering the rotation of individual features based on the data associated with each. Creating a custom display that is shown to the end user in a pop-up. Configuring labels that may combine one or more attributes of a feature. Calculating new field values based on values of another field. Or dynamically setting a feature symbol's transparency value. The Arcade editor is simple and intuitive. Along with a large area to write and view your code, there are references to functions that include documentation on their usage and a one-click ability to drop them right into your code. You also have the ability to test your expression before you commit it and have it run. Now let's take a look at a few live examples. Here we have a web map showing larger sized trees in the downtown area of Madison, Wisconsin. In our map, we have two layers. One, a layer of points representing trees that contains information on the species and the diameter of each tree. And two, a polygon layer showing the neighborhood associations for the surrounding area. By default, the web map simply shows me a listing of fields when I click on either of the layers. Let's use Arcade to make that pop-up more informative. In our scenario, when a user clicks on a neighborhood area, we want to have the number of trees that within that area displayed back to the user. By navigating to the pop-up configuration for the neighborhood association layer, I can find the area to create my Arcade expression. The first line of the expression will get a reference to the trees layer. And the second line of the expression will find which trees intersect that geometry of the neighborhood I clicked on and return the total count. And now that I have that expression, I can add it to my pop-up as a text content and format it a little bit more. I can also remove the fields listing since I don't want to have that show up in my pop-up. Now the pop-up is much more informative and presents the intended information clearly and effectively. Now I'd like to show you how to use Arcade within an Arcgis dashboard. Here we have a dashboard that is monitoring recent earthquakes around the world. We can view that information on the map, by magnitude in a chart, in a list on the side, and on the top with indicator widgets. These indicator widgets are each showing a breakdown of the number of earthquakes within a specific range of magnitude. Let's use Arcade to configure this last one here to show only those earthquakes that register a 5 and above. To do this, I'll open the configuration of the widget. I'll add a filter to my dataset. And I'll simply enable Arcade. This will open the Arcade editor within the configuration. I'll drop in my Arcade expression that will simply change the color of the text, the color of the background, and finally add an icon, give it a name, and this name can be referenced directly in the script. Once that's done, I now have an Arcade configured widget showing me earthquakes above a magnitude of 5. Arcade is an incredibly powerful, lightweight, and portable scripting solution that can be used a multitude of different ways across the apps and maps in ArcGIS. The JavaScript API continues to add new ways for developers to build powerful web apps with fast performance. You can tell your data story with rich, data-driven visualizations. It includes not only a variety of map styles, but also data-driven vector symbology. The most recent additions to the API have been extensive, including 2D clustering with labels, the blending of multiple layers together that produce new, interesting ways to see patterns in the data, optimizing performance for displaying datasets, both large and small, and since you're working with the actual features, you can build very interactive applications using the API's client-side analysis capabilities in both 2D and 3D. New 3D analysis tools, including 3D line of sight, a large collection of customizable widgets, and the inclusion of JavaScript modules for seamless integration in modern frameworks and developer tooling. This has been a frequent request that the API team is excited to deliver. Your applications need to be impactful. The API provides tools that allow end users to explore and reveal that impact. These tools enable you to show the where of something, the what of something, how much of something is occurring, when something has occurred, what and how much of something using multiple attributes at the same time, or in my something, what is most common, using a technique such as predominance mapping. You can explore patterns between different variables and visualizations. You can compare data over time, depth, age cohort, and so on. The API enables extremely fast visualizations. The sheer quantity of data that can be handled by the API will give you the ability to make your applications impactful. New cartographic techniques that may have once been limited to only the desktop GIS are now available to developers to use in web applications. Make user-selected features stand out in expressive new ways. Show data over time with visually appealing cartographic symbols and animated context layers that can help tell the story of the data. Included with the JavaScript API is a suite of configurable, pre-built widgets that wire up your data and help to decrease your overall development time. These widgets are ready to go. You can drop them in your application as is or customize them, so they work just as you like. And they work in both 2D and in 3D. Editing is also a key feature of many GIS web applications. Editing has never been easier, and the API team has enabled a seamless experience for the end user. These new features are available in both 2D and 3D editing. For more focused web editing experiences, Constraint-based snapping will ensure your applications maintain a high level of accuracy and overall data quality. The configuration of pop-ups has also advanced. With the latest version of the API, you can more easily integrate custom content within the pop-up itself. As the developer, you can encapsulate powerful workflows into simple user experience for the user, who never has to leave the pop-up. And finally, I'd like to make sure you're all aware that the JavaScript API is also available using Node Package Manager, or NPM. You can install the API locally for use with JavaScript frameworks such as React and Angular, and with module bundlers such as Webpack or Rollup.js. Exposing the API modules this way enables developers to bring along their framework of choice and simply integrate with it. Let's now take a look at a few examples for the Arcgis API for JavaScript. This sample visualizes the construction areas of more than 1 million buildings in New York City using a simple slider control. The slider allows the user to explore building construction relative to a specified year. A color visual variable is used to visualize each building based on its construction year relative to the slider value. For example, if the slider lands on 1970, then buildings built in 1970 are shaded with a light blue color. Buildings built prior to that year are progressively shaded along a blue to pink ramp, depending on the building year. Buildings built 20 plus years prior to the selected year are shaded with a pink color. In addition, we apply a bloom effect on the layer to make the buildings pop on the map. When the user clicks play to animate the slider between the years 1880 and 2017, they are shown a nice depiction of construction activity in that time span. This is a great example showing over 1 million features displayed in a rich, interactive visual way. In this sample, we are looking at an interactive 3D view of New York City. This application allows a user to explore the highest and most popular buildings in Manhattan. There are preset filters on the right to quickly show the top 20 buildings that, when enabled, not only filter the map view, but also the chart below. As the user interacts with the chart, the corresponding building is also highlighted on the map, zoomed to, and a pop-up is shown giving more information about the building. Moving from building to building is as easy as selecting a dot on the chart. Finally, this sample makes use of both pop-ups and the editor widget. It does this by demonstrating how to add a custom edit action to a pop-up template displayed in a pop-up. The pop-up displays a custom edit feature action. It works by starting an editor workflow for editing the attribute data. Edits can then be made and updated. Once this happens, the pop-up content is updated to display these feature edits. In addition to showing the custom editing action, the sample also demonstrates how you can use a custom function to generate 2 pop-up content elements. In this example, we show you how to display custom text content as well as attachments. If the specified field is updated, the text displays as a certain color in the pop-up itself. The Arcgis API for JavaScript is a full-featured modern API that enables developers to build rich, interactive web applications. With the latest enhancements and additions, you can get up and running and building your own dynamic, impactful applications in no time.
Hello, everyone. Thank you for attending our workshop today. This is Rami Al-Luta. I'm a solutions engineer working with Esri out of the Rotterdam office. I do support our global nonprofit program and our land administration program. Previously, I was working with Esri as a platform engineer out of the Dubai office. So let's get started with a dive in the Arcgis API for Python. For those of you who aren't familiar with our Arcgis API for Python, it's one of the APIs that are designed to work with your ArcGIS system, either online or enterprise. The Arcgis API for Python will enable you to tap into your different geospatial services, your different data sets, and manage your ArcGIS online organization. In this presentation, we will be having a brief look over all of these subjects in order to understand how can you utilize the Arcgis API for Python to make your life easier. So, what is Arcgis API for Python? Arcgis API for Python is a library for spatial analysis, mapping, and GIS. So all the tools that are available within our ArcGIS system are made available for you through different functions and classes through the ArcGIS API for Python. It is powerful, modern, and easy to use. You can use it in different places, and we will be going over these. It's powered by WebGIS with local capabilities, which means you can use your local applications, your local code, and power your WebGIS with it. It is made to make automation easier and data science easier. It's affordable, and all the developers can start right on from their ArcGIS online organization. So, automation with ArcGIS API for Python. We all have repetitive tasks that we work with on daily basis, moving data from one place to the other, converting different data sets, or making updates on the fly. These are time consuming, and if we're going through different clicks, we will end up losing a lot of time. We will end up with a lot of errors, and will have impact on our throughputs negatively. While if we automate these, all of these tasks, all of these repetitive tasks will be automated, which means our efficiency will improved. We have more time to do spatial analysis, for instance, rather than data migration and ETLing. We deliver constantly, and we're delivering the product that is promised. We're making sure we're avoiding all the errors, and we're increasing our productivity. So the ArcGIS API for Python, for those of you who are familiar with our REST API, it is wrapped over our REST API, and it's a Pythonic way to access your WebGIS, either your ArcGIS Enterprise, which is Portal, or your ArcGIS Online. It's easy to automate WebGIS tasks, and by that, these tasks can be organization administration, managing your users, your credit usage, your application usage, your groups, name it. Managing content, so whoever is owning a certain data type, a certain item in the organization, we can manage this Pythonically, and we can integrate data from outside of the org. We can move data in and out, and we can do all of the data science workflows that we might be using within our WebGIS ecosystem. So your WebGIS is what you're seeing in the middle, and the Python API will enable you to tackle all of these different subjects. We can be doing imagery analysis. We can be dealing with big data stores. We can be dealing with raster analytics, deep learning, data sciences. We can work on content publishing and updating our maps, our services, our tables that are available within our org or to the public. It is a powerful tool for all the developers, because the developers always want to extend their workflows. They want to plug in different tools from outside, different functions that they've worked on, and the Python API will enable you to do that. And it comes with its enterprise integration, which means we can manage our users, our roles, our privileges. So it's an administrative tool for those who know how to write Python. If we want to categorize the Python API, it fits under 3 models. So we can automate our WebGIS management, and we talked about the users, the groups, who owns what, how we determine the relationships of the items, who's owning this item, how we reassign context in case a user is out, so on and so forth. We can also automate content creation, which means we can update features, update tiles, update any existing item in our ArcGIS Online or Enterprise through different ETLs that we might create that tap into our data sources. In our presentation today, we would be tapping on Kobo server and seeing how to move data from Kobo into ArcGIS. We can also automate content publishing on off-peak hours, which means if we have a map that is updated on daily basis or weekly basis, we have data sets that are being updated, all of that can be automated in the environment. And then it's a tool for reproducible research, which means extending the usage of your services. And by that, we are tackling different data sets through big data, through data science, through understanding what's actually happening within our attributes and features. So the Python API will push the tools and combine different tools to come up with a certain understanding of your current analysis, or features. The Arcgis API for Python comes with different models that you can see within our API documentation. The main model is the GIS, where you tap into your content items, but that's not only it. You can do geocoding, you can do real-time, you can do feature management, widgets, mapping, geo-enrichment, dealing with geometry, you name it. So there's plenty of different models in there, and there's plenty of different capabilities that might come with the Arcgis API for Python. Today in our demos later, we will be tapping a little bit on the GIS and the features, because we're going to be dealing with updating features and with connecting to our GIS model in order to manage our users and our users' license, users' credits, so on and so forth. So there's plenty of different scenarios that we might be doing in there, but I'd like you to know that it's not only these. There's a lot, and I'd really ask every one of you to look into our documentation and give it a try in case you're interested in working with the GIS API for Python or the Arcgis API for Python. So within these models, the Arcgis API for Python will enable you to access the Arcgis platform or system in general. You might be working with desktop components. You might be working with enterprise components, with online, with different services. You might be working with only one piece, all with the whole image, and the Arcgis API for Python, along with ArcPy for desktop, whoever is familiar with that, will give you a powerful, handy tool to tap into all of these components. So you can work with Pro through notebooks in Pro. You can work with enterprise through ArcGIS notebook servers. You can work with online through ArcGIS notebooks online. And you can certainly use your notebooks of choice or your Python interpreters of choice and tap into all of these components. We will also be seeing how we can tap into different data APIs, for instance, Kobo, Geopol, you name it, any source of data that is live, that is coming from somewhere, and we want to move this data into our ArcGIS API. We can do that through our ArcGIS Python API. We can tap into the data API and automate the process, schedule the job, and make sure that our data is updated and always there for us. That said, I will be moving to our demo in order to get more hands-on experience on what can we do with ArcGIS Python for API. As discussed through the presentation, ArcGIS API for Python will enable you to automate and manage a lot of your workflows within ArcGIS Online or ArcGIS Enterprise. In this demo, I will be going over some of these capabilities through utilizing ArcGIS Online notebooks. After signing into my online organization, I will navigate to my content. There, I can locate the two notebooks that I will be working with. In this demo, I will be sharing with you two workflows. In the first one, I will go through processes of updating ArcGIS Online feature services with data feed from Kobo API. That is the first notebook you see here, which is GIS for Sustainable World Kobo. For the second part of this demo, I will be sharing some ways to manage ArcGIS users Pythonically, and that's with GIS for Sustainable World, a Goal Manager notebook. Our first pit stop is with the Kobo notebook. For those of you who aren't familiar with ArcGIS Online notebooks, they provide a versatile web-based interface for powerful geospatial data analysis. With notebooks, you can perform analysis, automate workflows, and immediately visualize data and analysis results in a geographic context. ArcGIS notebooks provide an integrated platform to create, share, and run data science, data management, and administrative scripts. Notebook authors can use Esri's Python resources, the ArcGIS API for Python, and ArcPy, and popular open source analytical, statistical, and machine learning libraries. In the first cell, I will import all the necessary libraries. For this workflow, ArcGIS libraries will be used to add and update data in the target feature service. Deep copy libraries to copy feature service template. requests to query Kobo API, and pandas to build the intermediate data frame. Note that running cells in notebooks can be as easy as clicking Control button plus Enter. As the cell runs, we will move to our next cell. In the next cell, I will define the variables needed for this exercise. The Kobo API source data on line 1, along with the requests and the raw Kobo JSON data. I will also define the fields I want to include from the Kobo requests and the target field names in my feature service. Finally, in this cell, I will use the GIS class to connect to my ArcGIS Online. You will notice that as I run the cell, getPassLibrary is requesting the password to connect to Kobo API. I will fill that in and hit Enter. You can see that the cell ran successfully. Next, I will define my target item along with creating a map item and adding my target feature service to it. You can see that in this cell where I'm using the get class from ArcGIS Online to get the item, and then gis.map to create a map item and map item.add layer to add the layer into my map. As I run this cell and I run the map item cell, I will see that the notebook created a map for me with the existing 2 points that exist in my feature service. These 2 points are having a unique global ID and they were edited by me with all the other features that are needed. As I move forward in this notebook and I reach the next cell, I will define the Kobo data frame. In the Kobo data frame, I will fetch the records that were requested from the Kobo API and add them into a pandas data frame. In the next cell, you can examine the Kobo data frame table shown in this notebook along with its associated attributes. In the next piece, I will be defining 2 functions, where the first one, fetch Kobo data, will loop through the queried data and build 2 dictionaries, Kobo data dic and attachments dic, with unique identifiers for Kobo data as a key. The first dictionary will hold the attributes for each Kobo feature, and the second will hold the attachments URL if they exist. You can see that I'm defining the fields and the variables here, and then I'm trying to add attachments if they exist in here and update the dictionary for attachments. As for the second function, update Argo feature services, this one will query the target feature service and gather all the unique IDs in the target unique IDs list that you see here. In the next chunk of this function, I will divide the queried Kobo data into 2 sections. The first one will handle creating features, and the second one will handle updating those that exist. You can see that there's a list for those to be updated and a list for those to be added. I'll query my feature, get all the data, and then append the target GUIDs into a list. In this list, I will loop through the data dic that I gathered from the Kobo function, and I will pick the IDs that don't exist in my target IDs. Those are features to be added to the feature service, and if they exist, then those are to be updated, and I will gather the records for these features also. The function will return data to add and data to update along with the feature layer template. In the next cell, I will call the first function that fetched the Kobo data and define a data dictionary along with an attachment dictionary. Those are happening on line 1, 2, 3. The next step is to call the next function, which will return two lists, one for data to add and one for data to update. That's the first one, and that's the second one. I will run these two cells and wait till they query and return back the lists. In the next cell, I will fetch the data to add, and I can see that's that already formatted with my geometry in there, with my spatial reference and all the associated attributes. Same for data to update, where I can see my geometry and I know that these exist in my target data set. In the next cell, I will call the edit feature class and use the add parameters to add new data and update parameters to update existing data. You can see that with edit features class, I have edits, and here I've got updates. I will run the cell, and as I can see, there's 2 new records added and 2 new records are updated. Next, I want to check for any attachments. And I can see that there is no attachments that are being added, mainly because the data that I fetched from Kobo got no attachments in there. Finally, I want to check the updates on the map. So I will repeat what I've done earlier on, recreate an item with my refugees location feature service, and I will create then a map and add that item to the map. If you recall on my previous map section that I'm going back to, I had 1 and 2 points. And now as I had 2 points to update and 2 points the app, I'm expecting that my map will update with these new features. And clearly, as you can see, the 2 points are maintained, yet there's 2 new points added. With this demo done, we are now ready to move to our next demo and learn how to manage ArcGIS online users with Arcgis API for Python. The first cell will import all the needed libraries, which we discussed in our earlier demo. I will then connect to our GIS and will define the user manager class from the Arcgis Python API. The cell runs successfully and ready to move to the next step. In the next step, I will query all the users and I'll define columns that I'm interested in as username, first name, last name, full name, email, role, and the last access date. In the below cell, I want to create a list for user information. This list is empty. I will then loop through with all users that I queried and define the username, the first name, and all the variables that we discussed above. The next step is appending that info to my users info list and creating a pandas data frame out of it. I will redraw my pandas data frame, and you can see that all the usernames from my organization are now there with the fields that I queried for them and the last access date. In the next step, I want to divide my data to users that never logged in, to users that logged in after 2019 or 1st of Jan 2019, and those who logged in between. I'm using the date 2000 here because any user that never logged in will automatically default to epoch 0, which dates back to 1969. On the next section, I'm gonna call the last access date and define the date time since the date comes in a string value and I want it as a date time format. I will then get the logged user filtered and I'll filter the logins that are active ones. On the next one, I want to filter those that logged in pre-2019. And on the last one, I'm filtering those users that never logged into my organization. If I run the cell after, I will see that those 5 users never logged into ArcGIS Online and therefore they are inactive. Then I want to see the logged users by year in order to have an idea of what's going on. I run the cell and I see that in 2015, 4 users logged in. In 2016, there's 12 users that never logged in since then. In 2020, 21, and this year there's 19 active users. I can use matplot libraries to plot a graph for these users and see how's my organization doing. The next thing I want to do is plot the users that I want to notify. These are all users that logged in before 2019 and sometime between 2015 and 2019. I do have their emails, I do have their full name, and I do have their role in there. Next, I'll move to the next cell where I group the users on these who have already logged into the organization but didn't log in after 2019. And I can see that there's 4 users that logged in 2015 and never logged in back into my organization, and so on and so forth for the other groups. I'll also plot a graph with matplot to show the activity of these different users. This is really handy for those who want to have a general knowledge of what's happening on their organization, and this workflow would be a great one for admins who want to manage their users in bulk and Pythonically. Moving forward, I want to notify the users that didn't log in. I loop through my users to notify data frame that I showed up, and then I'll define my username, my last access email, full name, subject of the email, and the message. For the sake of this demo and not to jam my colleagues with emails, I'm going to take the send notification function out of in the user manager class, and I'll make sure that I only send that message to myself, to my own account. In case I want to do it for the whole group, I'll just have to get this line back into the loop and add the username in this between the brackets here. So I'll run this and it returns true. The next thing I want to do is go to my email and look up for the message. And it says here, dear WMU viewer, this is an automated message produced for demo. So we are able to see that message. And actually the one I just sent came in at this time. And I can see that the user was notified on his activity. Moving forward, I want to see my inactive users, those that never logged in, and I might want to delete these because they're just occupying a space on my account. Also, for the sake of this demo and not to kick my colleagues out without getting their approval, I'm going to hash out the function, but you can see that it's as simple as connecting the user, getting the username from our never logged data frame, and calling the delete function. And that would be enough to remove all these users out. With this, I'll end up my demo and my presentation. I hope you had a great time learning about Python and the Python API and what we can do with ArcGIS notebooks. I'd also like to thank my colleague Adam for being part of this. Thank you.